you gonna do now?
Ever since the day you went away,
No, I don't know
how to erase your body from out my brain.
what you gonna do now.
Maybe I should just focus on me instead.
All I think about
All the nights we were tangled up in your bed. Oh no,
oh no,
oh no,
oh no.
you're going round in circles, got you stuck up in my head. Yeah, memories follow me left and right. I can feel you over here, I can feel you over here.
You take up every corner of my mind.
Your love stays with me day and night. I can feel you over here, I can feel you over here.
You take up every corner of my mind. What you gonna do now?
Ever since the day you went away,
Someone tell me
how much more do I gotta drink for the pain?
what you gonna do now.
You did things to me that I just can't forget.
Think about
All the nights we were tangled up in your bed. Oh no,
oh no,
oh no,
oh no.
you're going round in circles, got you stuck up in my head. Yeah, memories follow me left and right. I can feel you over here, I can feel you over here.
You take up every corner of my mind.
Your love stays with me day and night. I can feel you over here, I can feel you over here.
You take up every corner of my mind. What you gonna do now?
Did you know you're the one that got away? And even though, baby, I'm still not okay. Did you know that my dreams, they're all the same? Every time I close my eyes, memories follow me left and right. I can feel you over here, I can feel you over here.
You take up every corner
Of my mind.
What you gonna do?
Your love stays with me day and night. I can feel you over here, I can feel you over here.
You take up every corner of my mind. What you gonna do now?
I can feel you over here, I can feel you over here.
You take up every corner of my mind.
What you gonna do now?
이 노래는 It's about you baby Only you You 내가 힘들 때 울 것 같을 때 기운도 이제 나지 않을 때 It's you 날 걱정하니 It's you 날 웃게 하니 말은 해도 돼 But what do you say 멀리든 언제든지 달려와 바쁜 척도 없이 난 나타나 이게 말이 되니 난 물어봐 너는 말야 He's the one who's living in my system baby Oh my god Yes and yes on that I was really hoping that he will come through Oh my god 단 너뿐이야 Asking all the time about what I should do Now I can never let him go 너만 생각나 24 넌 행운 아야 정말로 I know 너를 알기 전까지는 나는 네 없어서 전부 다 내 맘이 끝이 없는 걸 I know I'm going crazy right 어디서든 몇 번이든 There ain't nothing else that I would hold on to I hear his lies through all the nights 잠시라도 내 손 놓지만 no 걱정 없잖아 Cause I got someone 혼자라도 괜찮아 Cause I love someone 멀리든 언제든지 달려와 바쁜 척도 없이 넌 나타나 이게 말이 되니 난 물어봐 너는 말이야 He's the one who's living in my system baby Oh my god Yes and yes on that I was really hoping that he will come through Oh my god 단 너뿐이야 Asking all the time about what I should do Now I can never let him go 너만 생각나 24 넌 행운 아야 정말로 I know 너를 알기 전까지는 나는 네 없어서 전부 다 내 맘이 끝이 없는 걸 I know I'm just living in my system baby can't sleep at night.
If you don't wanna see me, did a full 180, crazy, thinking about the way I was. Did the heartbreak change me? Maybe, but look at where I ended up. I'm all good already, so moved on. It's scary. I'm not where you left me at all. So if you don't wanna see me dancing with somebody, if you wanna believe that anything could stop me, don't show up, don't come out, don't start caring about me now. Walk away, you know how. Don't start caring about me now. Aren't you the guy who tried to hurt me with the word goodbye? Though it took some time to survive you, I'm better on the other side. I'm all good already, so moved on. It's scary. I'm not where you left me at all. So if you don't wanna see me dancing with somebody, if you wanna believe that anything could stop me, don't show up, don't come out, don't start caring about me now. Walk away, you know how. Don't start caring about me now. Don't start now. I'm not where you left me at all. So if you don't wanna see me dancing with somebody, if you wanna believe that anything could stop me, don't show up, don't show up, don't come out, don't come out, don't stop caring about me now, about me now. Walk away, you know how, don't stop caring about me now.
Hi everyone, hello, welcome to my YouTube channel. This video is sponsored by me, myself and I. Okay, so happy to see everyone here today. This is a replacement lecture class for the L3 and L4. Okay, so today we want to learn about chapter 2. Today, new week, new me, we go into a new chapter. But before that, we still have one more small section from the previous lecture one that I will cover, which is on the port number. So now I quickly teach you the port number, and after that I teach you one concept to finalize the whole chapter 1 and like a summary lah. Then today we start a new chapter. So today what we learn is local area network, I will show you the basic, the theory, the concept, and then I also show you today we got some unboxing that I want to do for you live in this channel. So I can show you some expensive device that you cannot normally see outside lah. Okay, so now yeah, just some announcement here. The video here that you see and the chat got a bit delay one, about 15 seconds. The reason is because I want you to be able to turn on the caption. So for those students who later you think I talk too fast, or maybe I speak like a Thai, you cannot understand my accent, you can turn on the subtitle, the CC button below, and then you can see the subtitle appear for you. Okay, now we start lecture class. Okay, now audio is clear. Anything that not clear, you let me know. Cannot see me, cannot hear me, let me know, because too long I never do streaming already. Last time I do it was about 1 year ago. Right, so now yeah, this lecture is from chapter 1, the last part where I already explained the IP MAC. So today we talk about the port number. Right, so in lecture 1 we learned about what is the internet, right? And then we learned that every time you want a device to connect to a network, minimum you need 3 things. IP address is the first one, port number, and MAC address. So these 3, like I said before, is like the brother that they cannot separate. You need to have IP, MAC, and port to be able to work, right, for the internet to work. So today we see what is port number exactly. Okay, so now port number is used to identify applications. Wait, let me bring this down first so that you don't see here. Okay, now it should be clear now. Okay, so we can continue. So port number is used to identify applications, right? So you see, this is an example where I get it from my iPad, where I have many apps. Now we buy device, like we have iPhone, we have iPad, we have MacBook. We don't buy one device just to do one thing, right? It's not like I buy an iPhone now and then this phone is only to play game, Mobile Legend. I don't do anything like WhatsApp on it. Or I buy an iPad and the iPad is only for me to watch YouTube. It cannot do anything else. No, it's not like that, right? Of course, I know like you may have one phone for one girlfriend. If you have many girlfriends, time management, that is different story. But the point here is that one device normally can do many things. So for example here, a device can run applications like a Google Chrome and also watch YouTube at the same time, and also maybe attending a Zoom meeting. So many things can happen in the background or at the same time on a same device that has the same IP and the MAC address. So here we need port number, because you see, the reason we need is, like I say, I have many applications that run. So the device need a way to know when a data come from the internet to your device. This data must go to what application, because so many is running. So let's say I got a data come in, data A. This data A, should it go to Facebook or Instagram or YouTube? Now, how the application know, how your device know? By using the port number. So it means that you see here, every device has a number. For example, the calendar apps use the port number 12345. The App Store can use a number 8411. Safari can use 85123. So Notes can use 8129. So these numbers, we call them port numbers. Now, the example I give you are all random numbers. This is not real one. It's not actually the number that they are using, but the point is the same. It's just to show that every apps must have a number which called a port number. So now you get why we need port number already, so that when a data come to my iPhone, say this is my iPhone, right? Now we need to be able to tell this data go to Instagram. If I go to Instagram, I want to see your story, then the data that received go to Instagram, cannot go to WhatsApp. It doesn't make sense by checking the port number. Okay, so yeah, the next thing is, you can see here, it is a decimal number ranging from 0 to 65535. Okay, so here the number is 0 to 65535, means that any number the app can use. Like let's say I have an app, I call it Instagram, let's say. Now I can use number like this. It works like this. It works as long as it's within the range of 0 to 65535. Okay, so why is this so? Now the reason is because you see the third statement here. The size of port numbers is 2 bytes, right? So if you remember, every kind of device, the address, they have their own size. For example, IPv4 is 32 bits, or we say this is 4 bytes. For example, 192.168.1.1. Still remember this? So this is 1 byte here, 1 byte here. This is 1 byte, 1 byte, 1 byte. So total 4 byte. Now for MAC address is 6 byte, if you still remember, or 48 bits. So this one here, it looks like that. For example, AA, BB, CC, 1, 2, 3, 4, 5, 6. Now see here, this is 1 byte, 2 byte, 3 byte, 4 byte, 5, 6. So total got 6 byte. Now for port number, it's very simple because it's just a number that we always see, that we use every day. It's just a decimal number, right? So here it is any number from 0 until 65535. Sorry, the reason is because now it is 2 bytes. Okay, so it's 2 bytes. So same thing, if I take the formula 2 to the power of 16. Now 2 bytes is 16 bits, right? So if I take 2 to the power of 16 here, I press the calculator. Okay, so you see, I press the calculator for you. I'm not good in math, so luckily we have calculator. So you see, if I do 2 to the power of 16 bit, I get 65535. This is why the maximum number you can use is 65535, because it's 2 bytes, which will give us this number 65535. Okay, so this is port number. So far, okay? Let me know on the chat if you're okay, because I don't know, sometimes I disconnected for 10 minutes and then I'm talking to myself. Let me know if you're okay. We go to the next one. The screen no show. The screen not showing. Is it? Oh, okay guys, sorry. I think I made a small mistake here. Too long no streaming already. Let me try again. I show you again. Now you tell me. Okay, we repeat everything. Wait. Hold on a minute, guys. I think I forget to turn on the screen. Oh, where is my... Okay, guys, never mind, very fast. Let me explain again what I just said earlier. Okay, thank you for telling me. Okay, so just now I was mentioning the size of port number. So again, very quickly, every address got different size. So IPv4 is 32 bits or 4 bytes. Okay, this one everyone remember 192.168.1.1, very easy. So you see here is 1 byte, 2 byte, 3 byte, 4 byte. So this is 4 byte. Okay, that is why we say that IP address is running out, because if you want to know the total number of address you can use, you can take 2 to the power of 32. Okay, now we can do that. You see, if I use my screen here, okay, you see I use my screen here, then I take 2 calculator, I take 2 to the power of, where is the power of, this one, 32. So this is a very big number. Now this is all the IP address that we can use. But of course it's not enough because in this world got too many people and too many devices. So we're actually running out. Right, that is for IP. Okay, for the second example, a MAC address. So MAC address, if you remember, it looks something like this: AA, BB, CC, 1, 2, 3, 4, 5, 6. So here is 1 byte, 2 byte, 3 byte, 4 byte, 5 byte, 6 byte. Now, so this one we know is a 48 bits or 6 bytes. Okay, so this one is the size of the MAC address. So today we talk about port number. Now port numbers is actually 2 bytes, as you've seen on the slide. So if you want to know the number which you can use to assign to the applications like your Facebook, your Instagram, and your TikTok, right? Now the number must range from any number starting from 0 until what now? You see 2 to the power of 16, because this one is 2 bytes, which also means 16 bits, right? So we can take the formula again, and then we do this, 2 to the power of 16. Sorry, press wrong. 2 to the power of 16, you get 65535. Now this is the value here, right? So this is why the total number, the port number that you can use is that one, 65535. Okay, so we go back to your slide. Okay, so far okay. Now we go to the next one. Let me know if you have any more problem, because sometimes too long already, I forget what to click also. Okay, next slide. Okay, now here in this slide, we want to learn about two different kind of port number. So you know what is port number used for already, right? You know that the port number is used so that we can give every app one number, so that the data come to a device, it is able to know this data is for what application. And then there are two kinds of port number. First one is a client port, the other one is the server port. Now look at this slide here. The white color bar that you can see on the slide is actually all the range of port numbers starting from 0 until 65535. Now among this number, there are some number that we allocate to be used by the server, and then there are some which we allocate to be used by the client only. So you see it's like that. Starting from the first number, okay, we start from 0, not 1. So 0 until 1023, which will give us 1024. Now all these number, the first 1024 number is for server. Server can use only, client cannot use. And then the rest one, starting from 1024 onwards until 65535, that one can be used by any client. Alright, so what is server and what is client? Now this one you have to understand first. Every time we do something that requires internet connection, so for example I use my phone now, and then I go to Instagram, let's say, okay, now in that case, in order for your phone to be able to display your Instagram story or Instagram post, your device, we call this a client device, alright, client device, need to connect to a server, and in this case it is the Instagram server. Okay, which is why we can say something like this. Okay, now every time we connect, we have this thing called client and server, right? Client is, this is the end device used by user to connect to server, and then you have another one called server, which is the running. Server is like the machine that running the service and waiting for client to connect. So we have client and server. Okay, this one you must take note lah. So everything that we do on the internet, okay, doesn't matter is it Facebook or Instagram or anything, or you play an online game, there is always client and server. So to make this very easy for you, you just have to remember like that. Client is the application that you have on your device, okay, and then the server is somewhere the company, like for example Meta, or Amazon or Google, they host their server and then they put it in the data center, right? So this one is normally kept in data center, and it keep all the data that you want to request to your device. So this is what we use a server for. That's why we have client and we have server. Alright, now very simple example. Let's say Weber. Today we go to Weber to download a slide. Now in this case, using a PC, let's say using a PC, okay? Now in this case, and then you use Google Chrome, let's say. This is the example that I want to show you lah. Okay, now that means your client device now is your PC, right? And then the client software now is Google Chrome, and the server you want to connect to is Weber server, which is the web server hosted by Utah, and this one is located in block A, in our campus block A. So you see, you got client and then you got server. Understand or not? Now, so based on what we want to learn here, the port number means that every time a data come to the PC, we know that all the PC got an IP, so it could be, for example, 1.2 or something like this, right? And then in the PC running many applications, one of the things that I'm running right now is Google Chrome, which I use to connect to Weber to download a slide. So this is Google Chrome. Now this one must have a client port number, alright? And this number is random. It is random. Any number from here 1024 until 65535 also can. So this is assigned by your operating system. For example, today you check, it can be 7878. Tomorrow you check out, it can be another number one, or it can be 9121, 9123, like that. This is client port. So this part understand, right? Okay, now then the other now the other one is this one, server. Now this server also got what we call the server port, and server port is different. It is not random. It must come from this number 0 until 1023, and it is fixed by this guy we call IANA, IANA in short, IANA. So remember last time I told you about a story where the US control the IPv4, right? Now specifically, US is very big lah. US, they have the president, they have the vice president, they have the NSA, also many FBI, right? So who actually control the IP is actually this guy called IANA, IANA, right? And they also control this number. Means that now today Weber is a web server and it must use port 80, or it must use port 80. Now, so what I want you to understand from this part is that all server must use a fixed port number assigned by IANA. So this number here, okay, it can be you can know this. For example, if I'm talking about something like this, IANA port number, see, I can do a Google search now. See, Google search, and then I go to this website. This is from Wiki, so if you're interested, you can actually go here and then find out more. Now you see here, this is the number. Can you see the number here? 0, 1, 2, 3, 4, 5. Now all this is the port. Okay, all these are the ports. Now if this is too small, then perhaps let me just make this a bit bigger for you. Okay, so you see, now then here got the description. In the description, it show you this number is used by what application, and that's why I say it is fixed. Now every program must follow this number. If you don't follow, then the nuclear bomb, the nuclear warhead will point to your house. Okay, so this one must follow. For example, I just give you port 80. Now you see port 80 is used by hypertext transfer protocol. Means that any web server, like anything, Weber, your Utah portal, they are all using port 80. Right? If you are playing other like you are using some other service, for example DNS, it is using 53. So based on this number, now it's a bit too early for you guys because this is our third class only. You don't know what is what yet. But what I want you to know is this table will tell you this number is used by what application, and this one cannot change one. Cannot change. It is fixed already one. Everyone in this world must follow this table. We call this the IANA port number table. Understand or not? Right? So you can see here now, all the number 0 until 1024. You see here, now you see until 1023 is fixed one. This one is fixed. You cannot use simply use. But starting from here onwards, now you see 1024 here onwards, it go from here until 655 something. This one anybody can use. You can use, I can use, your friend can use, your parent can use. If they know how to write a program, they can use this, so that your program can connect to the network. Now, and maybe you can just try out something. For example, if you play some game like FIFA, right? FIFA is online game, or maybe I say Steam. Steam, see, Steam is if you play game on PC, you know what is Steam, right? Now you see they also got the number, which is actually running a random port, because this is not fixed already. So it depends on whether you are running a server port which is fixed or a random port. Understand? Now all these number anyone can use one, you can also use it. Right, so let's go back to your slide, and then this slide here, okay? Just to sum up what we just learned. This example very simple. So now I'm using a web browser, then you can see on the left side. Now on the left side it says that I use port number 18291. I don't know whether this is a valid port or not. 65535. This is not a valid port, it's too big. Right, this one maybe you just take away the 2 18291 for example. So client port can be any number, server port must always on port 80. Okay, this is just a very simple example. Now this Now you know why we need port number already. Okay, so before I go to the next one, any questions before we go to the next one? Let me know on the chat or if you have any question. Hey guys, so screen, can you see the screen? I think everything is so far so good, huh? Right, okay, let me know on the chat if you're okay. Then we go on to the last slide for this lecture one already. Last one. Let me know. Am I still online? Oh, I'm not online anymore. Okay, now the last slide is we learned already. We got IP, we got MAC address, we got port number, and now you should already be able to tell like, okay, what is IP when we use IP? IP is used to identify hosts. Okay, when we use MAC address is used to identify hosts also, but it's using a hard MAC address. Why we use port number? So that we can know which application the data is going to. So 3. Now for the next part here is we want to combine all of them, and then we see how they actually work together so that the data can be transferred from one source to one destination. Okay, so this part here I will write something for you, and on your side I also need you to write this down. Okay, I also need you to write this down. Okay, now you see this very simple example. It will be always simple during the lecture, but in the exam you might see the same thing. It's not that simple anymore. Okay, so you better listen up. Okay, now here I got 3 servers. On the right side is all the server, and then you can see the cloud shape. The cloud shape actually means the internet. Okay, now on the left side here, this side here, okay, is my own network, and then this side here is the internet. So on the internet, of course, there are many servers. They have whatever we can do right now today. Definitely there is a server hosted somewhere on the internet. That's why we can access them. Like now I only show you 3 examples. Okay, so what we want to do here is also you need to see here. Now on this side here, you have the IP address of the PC1 and PC2. So I got 2 PC here. Now I want you to focus on PC1 only. For this example, we will only be looking at PC1. So here you can see that the PC1 got the IP address 192.168.1.1. The MAC address for PC1 is AABBCC11ABCD. Okay, and the port number is still empty. So for example number 1, what we want to learn now is we want to send a data. Can you see this box here that is moving right now? So you imagine this is the data that we want to send now. Okay, so right now I want to send this data from PC1, and then I go send to Instagram server. So you can think of this like, okay, I'm actually going to use my Instagram on PC1, and now we want to see how this packet travel from the source to the destination, and when this thing happen, how does the IP address change? Okay, so in the first example, we only focus on IP address. Now let's look at this box. Every time we send a data, what is sent is of course your data. So if I send you a picture of myself right now, so the data that I send is of course the picture, but in addition to that data, there is this thing we call metadata, which will guide the packet across the network so that it know how to go and where to go. Okay, and the 2 most important information inside is source IP and destination IP. So we have learned this before. Source IP is the IP address of the sender. Okay, of the sender. Now destination IP is where you want this packet to go. So in my example, let's say now the example is I want to send PC1. Okay, PC1 sends a data to Instagram server. Okay, so this is the example right now. Okay, in this case, the source IP will be 192.168.1.1 because PC1 sent. So PC1 is the sender. That means PC1 IP address will be the source IP 192.168.1.1 here. Right, now for the destination, where this guy is going to, it is going to Instagram server. So in that case, the IP address must be the server IP for Instagram, and in this case it is actually 3.208.4.201. So here in the destination, I will put in 3.208.4.201. that is the destination IP for this packet. Now of course this one will be different for every packet depending on who send what data to what destination. Now in this example, this is how it looks like. Alright, so very clear cut for this case. Now, so at this stage, what happened is we already built a packet which can travel from my PC1 to the server, and then the server will later on reply back to me lah. Okay, so here you see the packet will start to go and travel to the switch and to the router. Now switch and router are two networking devices which I'll introduce to you in the lecture 2. So for now you just imagine that they will just go in this way, and the packet will now arrive at the router. Okay, now router, you can know router because like when you have Unify, TM give you a router also. That is the router that I'm talking about here. Okay, now this one here is already here. Now in order for this packet to continue the journey to the server, something will change. Do you know what? Now that is this part here, right? So I want you to look at the next thing, which is the router. Now looking at the router, I got two address, private IP 192.168.1.254. Another one is public IP 121.123.29.230. So now I got two IP. Remember I teach you before, the private IP is used for you to send a data within your network. The public IP is used if you want to go outside your network to the internet. And in this case, it's very clear that we are going to the internet, right? Which is why we need to have a public IP. And you remember, you get this by paying your ISP, Unify, Maxis Fiber, and so on. Without paying, you won't have a public IP. And fortunately, in this case, we have one. Okay. Now, so what happened here is we will have to replace this IP, the source IP, to the public IP that the router has, which is 121.123.29.230. Okay, now let's take a look at this one again. So here 121.123.29.230. Now this one become the public IP already. So why like that? Why like that? Okay, now the reason is because you must know that the internet is very big, and anyone outside the network cannot see inside your network. Okay, let me repeat myself. So you see this one is my network, the one that I highlight. Okay, inside got two computers. Now anyone on the outside, when they want to talk to anyone on inside our network, they don't see our private IP. They don't see 192.168.1.1, 192.168.1.2. That one they cannot see. What they see is until the router only, which is here, this guy here, this router here, and they only see our public IP. So now you get it right. The public IP is used to go to the internet, and that's why it has to be globally unique, and every router has one public IP which you use like your passport to go to another country, and your IC number is used in our own Malaysia only. So here, this is why this number must change to the public IP. Now once this is done, the next thing is very easy, can continue. So it continue, go to the server. Now of course this one is not as simple as what I show you, just move like that. It goes through a very series of complex routing, and routing I will teach you on lecture 4. So for now, you just imagine it come to the server, done. So very far, come from PC to server also like take so much work, because it's really not easy. You see, you go to router, change IP, and then only you can reach the server. So now we have done one way only, but every time you send data, you must remember, you send something, the server must reply something back to you. It's always two-way one. That is why now I will show you another example on this packet come back from the server to PC1. Okay, now we see now if this is the case, the server now want to send data back to PC1. Who is the source? Who is the sender? This time it is the server already, it's not the PC anymore. So the server IP is 3.208.4.201, like that. Then the next one is where this is going to. Now this is going back to PC1, right? PC1, and we know that PC1 IP is 168.1.1. Okay, now remember, any outsider, anyone on the internet do not know our private IP. So if they want to reply back to us, they must put your public IP. So actually the correct answer is 192.168.29.230, which is the public IP here. Okay, now this is the data that the server will build so that they can reply back to you, and then the data will come to your router, go through routing, come back here. Now finally the data arrive at our home network. Okay, now this one here, the next part is there is two computers here. This data come here. How can we know that this data go to PC1 or go to PC2? Now luckily for us, remember just now when we changed the IP, right? So just now initially we changed the IP 192.168.1.1 to the public IP 121.123.29.230. Now when we do this process, this is all recorded. It's all recorded in a table we call a network address translation table. Now you can see from this word here, this is what we call NAT. So I want you to know this. The process changing the private IP to the public IP is called network address translation. Now this one here for datacom level, you only need to know until here, which means that there are something like that, but you don't have to really know how it really works. Okay, so now because we have this network address translation, when this data come back to the router, it is able to recover who is the original sender, and he know that this actually come from PC1, which is 192.168.1.1, and then it will now continue go inside and then reach PC1, and ta-da, I am home. Finally the data come back to PC1. Wow, so you see, feel like a very long journey. It took us 15 minutes to understand this. So now the next question is, can you understand how this works? From PC1 go to the router to the server, and from the server back to the router, and finally go to PC1. Can you understand or not? Let me know on the chat. Thank you. Is everything okay? Then we go to the next example. Okay. Yeah, very good. Okay, if got one people say yes, that means I assume everyone yes already. Thank you for helping me. Okay, at the same time, I also answer your questions. So if you have any questions, I think it's better you ask on the spot so that we know the context of the question. Okay, finally, this trimester, the first question I get is, how does someone IP get leaked while using the internet? Oh, alright, I think this is not really related to what we are learning here. This is more a cyber security question. So if I get your questions correctly, how does the IP get leaked mean that you are asking how do I know other people IP? Am I correct? I don't really get the questions. Maybe you can rephrase. But if that is what you mean, like how can we know other people IP address? Okay, that one actually is something called spoofing. We have this thing called IP spoofing, which you will learn more in cybersecurity. Okay, so Liam, I won't go into more detail, otherwise it confused our friend. But thank you for your question. Okay, now then we go to the next example. Right now, this next example is the same example, same network, same device, same server, same IP. The only difference is I want to show you how does the port number come into the picture, right? So we know how does IP works already, and now we see MAC address. Okay, now you actually won't see MAC address too much here because MAC address is a layer 2 one, and I will explain more about MAC address when we learn in lecture 3. So now we won't talk about MAC address, we just go straight to the port number, right? So port number is actually very simple. Okay, now I want you to look at this part here where you have a few number and then you have the service name. So 123 Facebook, 1989 Instagram, 8080 Avo Tech TV. It is a website, right? So now in every computer we maintain something called the port number table, right? So in all PC, doesn't matter you are using a Mac or you are using a Windows, you have this thing called a port number table, right? So this port number table keeps all the running applications name and the number. Now this is very important, just like what you see here. So if I have this kind of table, do you see this table? It means that next time if I receive a data and then I check the port, now here you see the data expanded. Just now we only have source and destination IP. Now we have two new things, source port and destination port, right? And based on this number later, we can know that this data is for what application. Is it for Facebook or Instagram or a website? Because most of the apps can be running at the same time together. That is why we have this port number. Okay, so if you really want to see the number, in fact you can, okay, on your Windows computer also can. Now you can actually go to your terminal. Where is my terminal? My terminal is gone. Let me find my terminal. I want to show this to you. Why I don't have terminal? Very weird. Oh, it's deleted already. I cannot show this to you then. Hold on guys, hold on. Let me find a terminal that I can use. First time I see command prompt can disappear from a computer. Let me try another one. This is different. Okay guys, never mind. Now I don't know where my terminal go. Something went wrong. My terminal went missing. But later during the break time, I'll find it back. Then I'll show you. Okay. Now for now, let's continue with the example lah. Alright, so the same example here. PC1 send the data to Instagram server. Okay, so the IP here I won't change already because we already learned this just on the previous slide. Okay, to recap. Now PC1 send to Instagram server. So the guy who make this data is PC1. That's why in the source IP it should be the sender IP address. So 192.168.1.1. Now this is going to 3.208.4.201, which is again the IP of Instagram server. Okay, delete server. Okay, now the next part here is source port and destination port. Right. Now for the source port, you must see this number. So for example, if now I am going to Instagram using my Google Chrome, so it's a web version of Instagram, not the app version. Okay, in that case, here you will put the number 71234. So this one can be like Chrome or Safari or any web browser that you use to go to the website. Okay, and then now the destination port is 1989. So this is a port which normally it can be port 80, but sometimes the server may be running on a different port, and in this case it's 1989, which is given here. And this is how it will look like after adding in the port number to what we already know earlier. Okay, so you see now what we have the source IP, which will guide us from a device to another device, and then we also have the source port, which will tell us this data is for what application. So the same thing here, it will come here, okay, and then here this one, remember to change to the public IP 123.29.230, and then come here, done, right? So now lastly, the reply from the server to PC1. Okay, so we will change the source IP now to the server IP, which is 32084.201, and then now this is going back to the public IP 123.29.230. So now another changes here is actually for the source port. Now this is a reply from the server, so the source port must be the server port 1989, and then it go back to your Google Chrome. For example, is 71234, like that. Then it will come here. Then it will come here. Okay, so when it come here, it will change this one back to 192.168.1.1 using network address translation. Then it come back to PC1. Now when this packet come here, he will know this one is for 1989. This is coming from 1989. So I will send this data to this one here. Hold on. Right, so I will send this data to this. 1989, which is Instagram. So you get it or not? This is how among so many data that your device receive every second, like 1 second they can get 1,000 or 10,000 of packets. They know that this one data A go to this app, data B go to that app is by looking at this port number. And if you understand, congratulations, that means that's it for lecture 1. So to sum the whole lecture 1 up, basically what you need to know is that we have IP, MAC and port, which must always work together so that the data can go from one point to another point and then finally come back to the original sender, and by using the IP, MAC and port number. Okay, do you know how it works together already? If okay, let me know on the chat, and then we go to chapter 2, week 2, chapter 2, new week, new me. Okay guys, can you follow? Do you still like datacom, or you already feel why I take this subject? Okay, whether you like it or you don't like it, you still have to do it because you want to pass your SEM 1. Okay, right, so yeah, we go to the next chapter on local area network. Now today I go very fast. I go fast so that I know it's already 7. Your food panda is waiting outside, so I don't want to drag too much. So we go straight to the chapter 2. And then let's start with the slide. Okay. Right, so what I'm going to learn in this chapter is I want to teach you how to build network. Okay, you see, every time you learn a subject, by the end of the class, if people ask you what you learn, you must be able to say, like, for programming, what you learn, you can write program in C++, I think, right? Or okay, then datacom, what you learn. Important thing is you can build network. Alright, and this is the first time you see this. What is a local area network? Right, so we'll start with the very basic, starting from a computer, and then 2 computers, and then 3 computers, and then we add from there. Okay, so now the first example you see here is that I got 2 computers, PC1 and PC2. Alright, you see on the screen. Now, initially in the very early days, okay, early day when we just have the internet, do you know that the device is not connected? So if you have a computer which is just sitting next to each other, physically they are very close to each other, but they cannot send data to each other because there is no connection between them. And it is when we started to design the Ethernet where we can connect a cable between them, then they can talk. So in the early days, even 2 computers side by side, like this is PC1, okay, it cannot see PC2 So you see, for PC1 point of view, there is no PC2. In fact, this is what you see, right? So the same thing for PC2. PC2 cannot see PC1, even though physically we see the 2 machines is just like neighbors sitting next to each other, but logically there is no connection between them. And then it is when we started to design Ethernet, then we can now connect 2 of them. So for example, the LAN cable, I take the cable, the one end I connect to PC1, and then I take the cable, the other end I connect to PC2, inside. Now they are connected together already. So in this case, right now, okay, now in this case means that now they see each other, and then you can start to do some data transfer from PC1 to PC2. So this is the first kind of network that we first have, which is why in the early day network is very small. Like for example, one network inside maybe got 2 computers only, or 3 computers. And the other thing is that the network doesn't go very far. So for example, if I'm in Malaysia right now, the computers that are connected together mostly are also very close, like in Malaysia. But our device cannot connect to Taiwan, cannot connect to the US. Because at those times we don't have the undersea cable yet. So we are only using Ethernet to link up all the devices which is like very close, maybe in one country only. So that time we call this peer-to-peer network. Okay, you see on the screen, this is called a peer-to-peer. Means that in this example, PC1 got a peer which is PC2. And for PC2 also got one peer, which is PC1. A very lonely, only 2 people. So PC1 can talk to PC2, PC2 can also talk to PC1, but only 2 people, quite lonely. Okay, and then eventually we upgrade the network to connect more hosts. So you know that now a local area network is actually connected a lot of devices. So you see this example here where now we got 3 computers already. We have 3 computers. So now guys, we have a situation. Now we got one more PC3 appear. Okay, now how can we connect 3 PC together leh? How leh? Now this is not some Taiwan drama which I ask you PC1 should choose PC2 or PC3. This one, what we want here is how can we connect all of them together so that they can send data among each other. Right, now in the case where you have 3 network device or more, 3 end device or more, it is time for us to use a network device. Okay, now this example is assume that all computer has only one port, which is why now you can only connect PC1 to PC2. So you see in this case, if we do a direct connection PC1 to PC2, then PC1 cannot connect to PC3 already, not enough port. Now another way is I take PC1, I connect it to PC3, but in this case then I have to disconnect it from PC2. So you see data transfer become very difficult if I want to do like ad hoc connections, where we call this ad hoc, means that it's direct point to point, means that every time I want to send data from that 2 PC, I have to go and connect them with one cable, and then the next time I want to do for another PC, I have to repeat the same process. It is not how network is supposed to be lor. That is why today we have this thing called networking devices, which we will use to build network. Now today I say I want to teach you how to build network. So before we can do that, you need to know what are the things that we can use to build network, and what are the thing is called a network switch. So in this case, starting from this time onward, you must understand when we build network, we never connect end device together directly. That means PC and PC cannot connect to directly. We have to connect them through a switch, for example in this case. Okay, now you see this is a switch where we use to connect all end device. Your PC is end device, PC1 is end device, PC2 is end device, 3 is end device. So now what we do is we take one cable and then we connect the cable from PC1 to the switch. Yeah. Then we repeat, we go to PC2, we take one cable, connect it to the switch. Yeah. Like that. Then we can also connect PC3 to the switch. So for example like that. So I move the PC closer a bit, otherwise too far cable, very long, expensive. So you see here, I connect PC3, and that once I do this, all 3 PC are connected to each other, they can see each other, and that is how we connect 3 or more devices. And definitely you need to use a switch in this case. Alright, so what you want to learn from this slide is that if you want to build a network, you need to know when to use what device. Later on you will see that I will introduce to you 2 more networking device. We have router and a hub as well. So later you will start to learn, okay, when I want to build network, I got 3 computers, I need to use a switch. This is something that you must know. Okay, right. So far so good, huh? Okay, let's continue. If you think that okay, that's it, the end, we have a network already, then that will be a very short lecture but actually it's not. Right, now in the network, okay, there is another thing that you need to know, which is there are servers inside network. Alright, this one, for example, you might not see it okay, in your home network. What you can see is your own device. For example, end devices like you have an iPhone, you have an iPad, a MacBook, a gaming PC or something else, okay, or you have a smart TV. Now all these end devices connect to the network, right? We see this every day because it's visible to us. But there is also servers in your home network which you don't see, and this server is for example like DNS, DHCP, and we call them supporting service. Without this server, your network cannot work. I confirm your network cannot work. So you see in a network, there is actually something else, which like for example a web server or a DNS server or a DHCP server. So what you see here in blue color are server. Now when we talk about server, what people traditionally think is like this. They think that server is something that look like that. Okay, so if you go Google how does a computer server look like, or they will think that okay, it's a very big piece of machine which take up a lot of space and it's very noisy and then it's very heaty, something like this, like, oh, this is a computer server, so big. You see this now, so big. Now yes, this is a server can be very big like what you see here, or server can also be very small, like very small. So for example, this is the router that TM give you, Unify router TM. I think it's a TP-Link router. Now see this router here, very small only. This guy is also a server, which means that inside your router there is some service that is running in order to support your PC1, PC2 and PC3. Understand or not? So in this slide, what it try to teach us is that in a local area network, there are a few things. First, you have the end device, which are like the device that we use to connect to the internet and the apps that we are running on them. And then we also have server, which is actually running inside your router. That's why the router is like the MVP, or one small device, the size so small but it can do so many things for us, is the MVP. But you don't really see that. You are using this service all the time, but you don't really notice that. Okay, so now we go to the next slide, which is on local area network. Why the screen is flickering? I don't know why. Okay, guys, we continue. Now the next one. So far you understand already what we have inside a local area network. Okay, now we have all the device connected to a switch, and when you do that, it means that all of them can actually send data from each other one. So that, for example, I mean this PC1 can send data to PC3, can send to PC2 and so on, because they are all connected already. Alright, so the next thing is, network is not just your home network. You can imagine that this yellow color one that you see right now is your network. But how does the internet look like? Anybody know how does the internet look like? Is it a device, or is it a connection or something, right? So here you can see that the internet is actually a collection of all this land. That means that in this world there are so many networks. I have my own network, maybe like that, okay? And this network must connect to a router. So you see here, what I do now is I take this whole network, okay? I connect this network to a router. Now why I do this is because my LAN, if I don't use a router, it is only local, means that it can only talk among all the devices that you see here, which is connected to the switch together. But they cannot talk to anyone outside the network anymore. So in order for our device in our home network to talk to people outside our network, we need to connect them to the router, and then this router will later on connect to the internet as what you see here, right? So let me hide myself so that you can see. Okay, so yeah, here, do you see that? Now this is how a typical local area network looks like. So from the start is all the device that you have, you connect to a switch so that they get connectivity, and then you connect the switch to the router. You see, we don't connect all your end device like PC1, PC2, PC3 to the router directly. Instead, we connect all of them to the switch first, and then from the switch, only one connection. See, only one connection from the switch to the router. Okay, and then you go to the internet. So this cloud here means the internet, right? Now, the next part is that, okay, I appear back again. Okay, I'm back. The internet is like this one. If you have one network, for example, this can be my network. Okay, I connect to the router. Then you also have your own network, like this one. Maybe this yellow color one is your network. And then your friend also got one network. Then your friend brother also got one network. Your friend brother sister also got one network. So we got so many home network together. And all of these network connect, they have their own router of course, and then they will all be connected together so that we can send data to each other. That is why you see, no matter where we are right now you are watching this YouTube live. I'm streaming from Kampar. Some of you may be in Kampar, some of you may be in KL already, or some of you may be in Penang. But we all can see the same video because all our network connect together, and this one is actually how the internet looks like. Internet is not a device, it's not a program, it's all our network connected together, right? Okay, now if you understand, then we can go to the next one already, which is networking device. So before we continue, I want to answer some of your questions first. If you have any, please type on the chat. Do some Q&A. Oh, we have one question from earlier. How did PC1 recognize and send data to the router in the first place? Oh, this is a very good question. Thank you for your question, Ling Hong. Okay, now guys, your friend asked this question. This one is the example from earlier one. Okay, earlier one in chapter 1. Okay, so he asked the PC1, when I want to send data to Instagram, how do you know what to send to the router? Now, this is by default. Okay, by default, all device, including your PC, your phone, and everything, they will check the data destination. Okay, now very good question because you asked your friend can learn more. So only two things can happen. If a data is sent to a host in the same LAN, right? Then this data is sent to the switch. If the data is sent to a host outside your LAN, or we say this is the internet, right? Then the data is sent to router. Now this is by default is programmed into all computer. We call this the TCP/IP stack, which you will learn more in the future. But you see, this is why just now in the example I show you the data go to the router, because the computer when they send data they will check one. So they will check this data want to go to who. So I can use back this example that I have here. Okay, let's use this example that I have here. This very good question. Okay, now you see, let's say I got another network here, and inside this network I got computer. Okay, sorry I didn't take art lesson when I was young, so I hope you can see what I'm drawing here. Okay, so see this one. Now if I talking about PC1, okay, he want to send the data, and let's say the data is sent PC1 sent to PC3 like that. So this data here, when we want to send, it will go from here and then it go to the switch and it go to PC3 directly. It will not go to the router. Understand? Now, if another example, PC1 send a data to, let's say we call this PC8. Okay, so we send data to PC8. Now the same piece of data now, it will see that because the destination that I want to go to is not in my own LAN, it is outside. So I will send this data to the router. Do you understand what I mean? So just to repeat, the data they will check if I want to send to someone which is already in the same network. So for example, it's just my neighbor or the computer next to me, I just send to the switch. If I want to go to the internet, I send it to the router. Okay, did I answer your question? Let me know if you are not clear. Okay, now next one. Let's see if we have any more questions. Okay or not, Ling Hong? Understand? Understand? I hope I answer your question. Okay, now we go to the next one. If no further questions, now guys, the next part of this lecture is we want to learn how to build network, and before that you need to know what are the things we use to build. Okay, now today I want to teach you 3 network devices: hub, switch, and router. Okay, actually in fact the whole datacom class, okay, there is only 3 devices that you need to learn, and you need to be very good in this. So let's start with the first one. As I explain, I will show you how this looks like. Okay, now very briefly, it's very briefly first because I don't want to go into too much detail yet. I just want you to know that we have 3 to choose from. Either it's a hub, a switch, or a router. Now the router is the most expensive device that you can use to build network. Let me show you a real example. Okay guys, welcome to my unboxing video. Now I'm going to unbox this, and then I want to show you how it looks like and all the ports that you have lah. Okay, now unboxing time. So router is something that you should be very familiar, because if you have internet today, which means that you have a router in your home. Okay, but the router looks very different. Wait, let me take something. Okay guys, so this is the router that you normally see. Okay, this one here, right? Like if you have Wi-Fi right now, I'm sure you have one of these, and this is what allows us to connect to the internet, like I said before. So if you read from the slide, router is used to connect multiple networks together, and without router we don't have internet access. We can only have LAN, local area network access. So this is a router. Now this is what we call a home router, which is used by consumer, people like me and you, and people who want to have internet at your home. Then we have this kind of router. Okay, now the different router I want to show you later is an ISP router, which is used by the internet service provider, like for example TM, Maxis, Unify, which they use to link up the whole world. That is different. So the router that you see here is probably about 100 something. If you want to upgrade this one, maybe it's late, you are a gamer, and latency is very important. Every time I play game I lose, so I blame the router. Then I get a newer class speed router, for example. It will cost you about 500, 600. It won't be too expensive, right? But it's still the same, it's still a router. Now what I want to show you now is an industrial grade router, which is programmable, which means that you can actually do some programming and coding to the router. That's why it's so expensive. Okay, let's do the unboxing right now. Okay, now I have the box here. Inside this is a router. Okay, this is the cable that comes with the router. I will also show you the cable so that you know how you're going to connect the router later. And then power cable. Okay, throw to the side. And then this is what we want to see, the real industry grade router. Okay, now guys, this thing here, see, so big, so heavy. Compared to what we have earlier, this is like so much bigger. What I holding here in my hand is about 10,000 my salary. So if I like just drop it accidentally, then gone, 1 month's salary gone. I work for free this month because this one is very expensive. Right, so you see here, first thing is it look very different. At the back, if you look at the router, a real router that you have seen before, at the back is like this. Okay, it's like this. So it's many ports where you can connect a LAN cable to, and then from there you connect this end to the other end, which is your computer, let's say, and then that's how you get internet. Or you can also connect using this one is for Wi-Fi, right? But in this kind of router, there is no such thing, because again, you must know this is not used by home. If you go to your friend's house today, and then you check, suddenly you saw they connect to internet using this kind of router, that time I tell you, you marry this guy, because this guy must be very rich. No people use 10,000 router to just connect to the internet. This is used by the ISP, right? So now if you look at the back here, now this one is very different. So I want you to see closely at the back here. Okay, I think this is a good view, and then we'll start by one. Okay. This is the other way already. Okay, now that's better. Can see, right? Yeah, I unboxed the device because you pay me so much money so that I can show this to you. Right, now the next one here. Guys, today when I teach you this class, I'm going to skip the slide here and there so that you can get a good continuity of what I want you to learn. So the next slide I want you to go down a bit to the cable and connections, and then you find the slide which shows the serial cable. Okay, and yeah, probably this is the one here. Okay, I want you to go to this slide. Go here. Yeah, this slide, serial cable. Now, next I want to show you this cable. Okay, this cable is used to connect routers. Okay, you see, this is a very big cable. You cannot go and buy this cable one. You can buy LAN cable, you can buy so many different cable, but you cannot buy this cable because this one comes with a router. Means that when you buy the expensive router, it comes inside the box. And you see it's very big. This one is not a normal cable that you see day in, day out, right? So let's look at the end here. So the both end here actually looks the same. This one we call this a serial connections. Okay, it's a serial port. Now why we have this cable is to connect router and router. So that means if I have two router and I want to connect these two router together so that they become the internet, this is the cable that I use. Understand? So if I go back to the router, if you see this is the back of the router, right? And then it didn't really focus. Let me yeah, this one. Okay, I want you to look at this one. So you see this is called a serial one. If you see this part here, right, it's called a serial one. See this? Now this is where I put in this cable. Let's do it. Right, so this side here will come here like that. You see that? Or I can put here, then you can see better like that. So it goes in here, and the other end, the other side will go into another router. So another router that looks like this, and this is actually the internet. If you really go and check the backbone internet, there is a lot of this kind of router connected together using this cable. That is why I say this cable is not commonly found, because it's used by the ISP, right? So now if you go back to your slide now, and then we see this one. Okay, guys, I won't explain too much. A serial cable is used to connect the device that use a serial communication protocol. So router that is they also support serial communication. That's why you can use a serial cable. The cable typically has a 9-pin or 25-pin connector. Now, if you really want, you can actually count this one. Where I count for you, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it's real. They didn't lie. It's real. 9-pin. Okay, and then it transmits data 1 bit at a time over a single communication line, and is typically used to connect router of an enterprise network to the internet. Now, guys, the whole slide got so many words now. The only important line is the last one. Used to connect router to the internet. That is the only important thing, right? So that is a serial cable. Okay, so I think you have seen the serial cable. Next, I want to show you the next kind of cable that we use to connect. Okay, now this is a console cable. Wait. Okay, now the other cable that I get from the box, it looks like that. Okay, this one. So guys, we are in the next slide, and this is called console cable, or sometimes it's called a rollover cable. It's come in light blue color. Okay, this one light blue color, and the head two end is different one. So one end here, this one is called RJ45. This one is actually similar to a LAN cable, so it's like the normal Ethernet cable that we have seen so many times. It's very common. And this one is I think it's called RS232, which we connect to the computer. So what is this cable used for? Let's look at the slide. Now, a rollover cable is used to connect a computer or device to the console port of a router. This is typically used for the initial configuration and troubleshooting of the device. The cable has a serial communication connection at one end and an RJ45 at the other end. That's why you see just now I show you it's different. Now the rollover cable is only used for configurations but not data transfer. Okay, now then why we have this kind of cable? Okay, you see this cable. No, I think I should show you this router. Okay, this router. Guys, I want to ask you a question. I don't know whether you are still here with me or you're already enjoying or not. Okay, so I ask you a question. This router here right now, I want to set up this router. For example, I work in Huawei or Cisco. Say Cisco because it is Cisco brand. Later they sponsor my video. Okay, so now I want to set up this beautiful boy, pretty boy. How can I do it? See this device. There is no keyboard, there is no mouse, there is no monitor, there is no input and output. So how do we set up a router? What do you think? Like a computer is different because we have the input and output where you can type in the command. When you do programming, you type on the keyboard. But a router is just like a CPU without display, without keyboard and mouse. So how can we do configuration? Anybody can tell me on the chat. Sir, isn't that VGA? No, that is not VGA. It's prettier than VGA, light blue color, light blue. Okay, give away can. If this is my last trimester here, I give away. But the Bitcoin still haven't go up, so I will still be here. I cannot give away. Right, finally someone answered correctly. Use serial cable. Oh, it's not correct, but good try. Okay, the answer is use console cable. I typed in the chat for you. Okay, which is the one light blue color one. So if you want to configure a router, you must know that this is real. Even if one day you go to work, it is like that. You don't have a display. That is why you need to have this thing connected to a device that already have input output. And the best one is your computer, because your computer already have mouse and keyboard and monitor. So what we want to do is we will connect this router right now to a PC, and then we use the keyboard on the computer to set up this router, and we use the display of the computer to see what we are typing. Understand? So it's like you connect an external drive to your computer. Now we connect a router, but of course the connection is a bit different. So this is how we do it, right? So you take this cable here, and the one that looks like the LAN port, we call this RJ45, will go into this light blue color one. So you see this console here. Now this console is where I connect this port here. So ready for some ASMR action coming. Let you hear it. ASMR tiap into the console, and then the other end, this side here, okay, this side here, go to the back of your computer. So of course your computer must be able to support this port lah. If your laptop of course cannot lah, because your laptop don't have this port. But if you have a desktop CPU, you see the back got this one. This is why we use that port, so that you can connect this kind of networking device, and then you can do some configurations on it. Understand? So this one go to the console, and this one go to the back of the computer, and then you can use the mouse and keyboard on the computer to set up this router. Understand? And that is how we use a console cable. Very good. Now then we go back to the slide. So you can see from the slide, one go to the console on the router, the other go to the PC. So the next one here. Okay guys, next question. You give me 1 minute, I want to go and take something. Okay, I come back already. I know you hope I don't come back, but always come back. Okay, now the next one here is the Ethernet cable. So right, Ethernet cable is something that we already learned. Okay, in the first lecture I showed you already. One of the factors that sometimes affect your speed of the internet is because you use an older cable which cannot support the high speed that you want. and on the table is the same one that we've seen earlier. You can see like, okay, cat 5 is 100, cat 5e is 1000, cat 6 is 1000, cat 6a is 10,000. So this table you have to remember, so that let's say in the exam you have a questions like that, then you can know, okay, this kind of cable, how fast is the speed that it can support, right? So that is cat cable, you've seen before. Now today what I show you again, because I want to show you my collection of cat cable. I collect cat cable like Thanos collect Infinity Stone. Wait Okay, so now this is the cat cable. You already know before, this head is called RJ45, which is why it's very similar to the console port, the light blue one that you see. Okay, so you see so many color, yellow, so I have so many color. Okay, green color one is eco-friendly, save electricity. Red color one is fireproof, fireproof. So let's say you use red color one day your building on fire, burn the whole building, the only thing left is this red color cable. Green color one is lightning, faster speed, and blue color one is waterproof, so you can spill coffee on it. Okay, forget what I just said. Everything that I just said is not true. Okay, hey, anyone actually believe it? No. This cable, the color, it doesn't make any difference. Okay, all the color is the same. What make difference is inside, what we cannot see. So just to repeat what we learned in lecture 1, the inside of this cable can be cat 5, 6, 7, 8, depending on how many twisted pair cable they have. Now of course I cannot unbox this thing for you to see but yeah, if you have more cables here, then the speed will be faster. So that is Ethernet cable. Right, so now why we want to learn this? Because I want you to look at the next part of the router, which is here. Okay, now you already take note. Congratulations, you can write that in the exam, or you write that in the exam. Hopefully I'm the one who mark that. So different color cable for your Christmas tree lah. The color doesn't make any difference. Okay, now come back to the router. Here got 1, 2, 3, 4. See that 1, 2, 3, 4. Now my question to you is, if I want to build network, just now we already learned every network need a router, so we can go to the internet, right? And that means every time we connect a switch to a router, it becomes a network. Now based on this router that I have here with 4 ports, how many local area network you think I can build? Is it 1, 2, 3, or 4, or 5, or 6? Let me know on the chat. Give a try. Is it 1, 2, 3, 4, 5, 6? Or cannot? Or 0? You let me know on the chat. How many network can be built with this one? Yeah, I wait for your answer, then I continue. YouTube chat, there's a bit of delay. Anyone can tell me, is it 1, 2, 3, 4, 5, 6? You have become Dora again. 2. Okay. 1. Carlson say 2. Kyson say 1. Oh, your names sound so similar. Kyson and Kyson. 2, 2, 4. Oh, okay. More people say 2. Very good. That means this time Datacom many people get A. Right. The people who say 2 is correct. But if you say other than that, it's okay. Good try. Now, why I want you to know this is because now let's look at this a little bit. Okay. You see the FE01 and FE00. Do you see this and this one? Now this one we call this the fast Ethernet, which is where we connect this cable. So if I take this kind of cable, I connect it here, right? Like that. ASMR. Then I go to the other side. I go to maybe a switch. So this one will become one network. Okay, I can do the same thing here. Let's say I use the green color cable. Okay, then I connect to the other side like this. Now I connect here one more. Then this is 2 network, 1 and 2. Like that. Here got 2 network already. See that? Now, then why is it not 4? Because I got 4 here. So you must know that when we build network, you can only use the one labeled with FE01 or FE00, okay? Or sometimes in the newer model one, it can be a gigabit port, so it's G01, G00. Now, so what it means is the console port is never used for data transfer. It was in the slide earlier. So this means that this port is only for you to connect the console cable, which you connect to a computer, and then you can configure the router. You cannot use this port to build a network because there is no data transfer here. And the same thing for aux. Aux is very similar to console, where you can also connect these to a machines, which you can do some troubleshooting and configure the router. But again, this is like not very often used. So these two port is not for you to build network. Only these two on the left side can build network. So the answer is 2. This and this, like that. Okay. Now of course, sometimes you want to build more and more network, because 2 maybe is not enough. Maybe what if I want 3 or 4? So you see here, this part here is the expansion card, where you can actually buy some new module and then you connect it so that you can have more of this thing, and then you can connect more network. So it's just like if you have a gaming PC. Today I use RTX 3090. I play game, always lose. Then I blame the computer. Yeah, my graphic card is not good enough. Then I want to change to 4090. Can, because on your computer you can put so many different graphic cards, combine them together, right? So it's the same concept here. You can always buy expansion card to increase the port you have on a router so that you can build more network with that router. Okay. Yeah, now we are almost at the end of this class. I'm not sure whether the stream quality is okay for you now, because I noticed the connection are dropping sometimes now. So hopefully it's good on your side. Right, now we will finish up the router part. The other part, this one no need to show lah. This is the power cable. Okay, power cable. Without power cannot work. So this is just the power cable, and that is it for router. Now we will go to the next networking device, and now I want to show you what is a switch and how it looks like. Okay, now we go to the second device. Is called a switch. So from the slide, let's read. The switch is to connect device within a local area network together, meaning that if I have a few devices that I want them to connect together, I connect them to a switch. Now switch only understand MAC address, but only understand MAC address, and then it can be 8 ports, 16 ports, 24 ports, depending on how many devices you want to connect. So of course, more ports means more expensive. Now switch is comparably cheaper than a router with the same number of ports, and it is better network security compared to hub. Okay, now I'm reading the slide but later on I'll give you example for each of them. Okay, now let's continue with the switch. We see how it looks like first. Okay, now this is how a switch looks. I have a switch here. Looks very similar, like I've seen this before, but it's not the same thing. Router is also the same design, but this one is a bit smaller. Router is a bit bigger. That's why router is more expensive. Now of course they look the same, but they work very differently. You must know a router is for us to connect ourselves to the internet. This guy here is for us to connect all the devices so that we can build our own local area network, that we can talk to each other only, but not the people outside our LAN. Okay, so at the back of this switch, you can see that it's almost very similar to a router, and you can see this is an 8 ports switch. 1, 2, 3, 4, 5, 6, 7, 8, meaning that I can connect 8 devices together in my LAN. So if I have PC 1 until PC 8, then this is sufficient. I have enough ports. If I want to connect 10 computers, then this is not enough. I need to upgrade. Maybe I buy a more expensive model which can support 16 ports at the back, or you also have 24 or 48 depending on how many you need. Okay, so this is like, you get the drill. This is where I connect this one here, and then connect like that, and the other side connect to the computer. This one connect to the computer. Then if I have 2 of these like that, then this one connect to another computer. These two computers will be able to send data to each other already. You don't have to pay anything. No need to pay Unify or pay to TM because it's only for internal local area connection. Now again, you also see that it has the same console port here. Why cannot take out? Okay, console port here, which you get what I want to say already lah. Where you want to configure the switch, then you connect the console to the switch and then the other side to the computer, and you can configure the switch. So meaning that this switch also can be programmable. You can also type command and then make some changes to the switch. But everything that you've seen today, including the router and the switch that I show you right now, they are all command based, which is why Datacom you learn a lot of command on how to make setting inside this one. It's not mouse, it's not UI where you can just click and then that's it. You have to really learn what is the command to do certain thing, and then you configure this so that it works the way you want it to be. That is part of building network. Building network is not just pull cable and then that's it. You still have to do some command and configuration. And this is a programmable switch that you see here. Okay. Of course, if I can choose, I choose Nintendo Switch. This is not the kind of switch I want. But last time during Christmas, I asked Santa to give me a switch. But the next day I opened is a Cisco switch, and that's how I end up become a networking guy today. I also wish this is a Nintendo Switch. Okay, now there is a switch. We have seen this already. And the last device today I want to show you is a hub. Okay, wait a minute, let me get a hub for you. Feel like my house very big, can put so many things. Isn't the router should be connected to modem? This is a very good question again. Okay, before I show you the hub, I want to answer this question because your friend White Mochi asked a very good question. Now, your friend is correct. So, every time you look at if you check your router now, I don't know whether you know where is your router, but if you know where is it in your house, you can go and take a look now. Yeah. Now, these two devices. This one here, this is a router now. This is a switch. You check your own home network, they don't have two devices. Actually, there is two devices, but the router that you have is actually a combo device of switch and a router. So what I mean is, when you subscribe to TM Unify, the technician come and then they pull some fiber optic cable inside and then they give you two devices, right? So the first device is actually the modem, and the other device is a router. So let me explain a little bit more. Okay, now it like that one, like that. Okay, now you see this is your house lor. Okay, maybe you stay in bungalow. I draw 3 floor, bigger one. Okay, then outside got the tiang one. This is all the cable. Now there are some fiber cable which one of them they have to pull into your house. Okay, pull into your house. So let's say you ask the telco to put the router somewhere here. Now they'll give you two devices. Okay, the first device that connect here, this one is actually a modem. Right, so this is a modem. Okay, and then this device will later connect to another device, and that is your router. Okay, that is why you got two devices like I mentioned. So this is your router. Now, but I just teach you in networking, you need switch and router. The switch is connect all the PC in your house. For example, you have a PC or you have a phone or you have an iPad. Now all these end device must connect to your router, to a switch, not a router. And then the switch go to the router. This is what we learned. Okay, now, but why you see here is different is because this device that TM give to you is 2-in-1. It's a router plus switch combo. That means that this device you see is 2-in-1. That is the reason all the device you have in your home network will only connect to one device, which is the Wi-Fi. Or if you use wire, then it is the wired that connect to the router. So you connect to the wireless router. We call this your Wi-Fi network, and that all internally, all these devices, when you want to connect them together, this router is also a switch, so it can connect all the device in a local area network. And at the same time, it is also a router which it will connect to the modem here and then go to the internet somewhere outside. So that's why you don't see switch and router, because it's already combined into one device, 2-in-1. DM so good, they want to save your electricity. And then this modem, what is this used? This is different. This modem here is used to convert the signal. Like for example, analog to digital signal. So this one is different. So for example, the signal that travel on this cable, so maybe you want to see all this cable here, the signal can travel. It can be like this, a sine wave, depending on whether you are using a copper cable or a fiber optic cable, right? So all these are data, but in order for your machines to understand, you need to convert this thing to something that looks more discrete like this. Also, it will know this is 1 0 1 0, and then 1 0 here, 1 0 1 0 1 like that. So this is what a modem do. From the analog signal, they convert into digital and then they send to your router so that your router can understand. That is why you got two devices. One is router switch, another one is modem. Okay, I hope I answer your question. Then if you okay, we can go back to your slide. I only have one more device to show you today, the last one. And then next week, tomorrow we have another online class. Hey, don't forget, okay, we have online class. And I will continue for the rest now. So now I'll show you what is a hub and how it looks like. Today I haven't shown you when to use what, okay, I just show you how it looks like first, and tomorrow I will show you when you should use a switch, when to use a router, when to use a hub. Okay. Any more question? Oh, hungry already, huh? Okay, so Mochi, I hope I answer your question already. Let me know if you think that you need more better, clearer answer, then let me know. Okay, guys, meanwhile, this is how a hub looks like. I need more monitor. This monitor not enough. Okay. Unboxing again, last unboxing of today, but this is the cheapest thing, okay? This is like the kind of thing, if you today you leave it somewhere and then you forget to take it back, the next day you come, it's still there because nobody want it. It's very cheap. If you want to buy this, you can get it from Lazada for like about 30 ringgit, you can get one already. Okay, so why this thing is so cheap then? It's because we call this hub a layer 1 device, and another way to call this is a dumb device. Dumb means that he don't really understand anything. Then why do we need a hub? What is it used for? Right, so a hub, it looks like this. Okay, you see, I have a model, it looks like white color one. So even the design is, okay, design is not bad, white color bin. White color always bin. Okay, now at the back, it looks very, very similar to a switch. In fact, if I put them side by side, now you can see this for yourself, is actually like so many ports. So I have an 8-port switch, I also have 8-port hubs. They are actually like the same thing, and really they also do the same thing. Okay, so to make this simple to everyone, if you read the slide for the hub, okay, read the slide for the hub, you see a hub is used to connect multiple devices to form a LAN, which is the same thing as a switch, what a switch does. So it's not wrong, it's correct. Hub and switch is both used for the same reason, where we want to connect all our end devices together to form a local area network. Now the difference is only visible here. In the case where hub and switch, if you compare them, okay, if you compare them side by side, this guy is a lot cheaper compared to this guy here. So a hub is cheaper compared to a switch, even though the ports that they have is the same. So 8-port hub is cheaper than this guy, 8-port. Okay, why? It's because this guy is dumb device, meaning that it doesn't understand how packet works. It works as a broadcast device where anything that comes to this device, it will be sent out to everyone else. Now I'll explain more about how this thing broadcasts and how this is different from a switch in the next lecture when I'll be using an example so it's become clearer. So for now, you just have to think that comparing these two, although they do the same thing, this guy is cheaper because whatever a switch can do, whatever a hub can do, switch can do, but it do it better. So whatever a switch can do, a router can do also, and it do it better. That's why this is the cheapest one, this is the second one in the middle, and then the router is the most expensive one. It's like a family with 3 guys. So the router is like the smart kid, the guy who always make the parent proud, and the switch is like somewhere in the middle, not too good, not too bad, and this guy is like the son that I'll never tell people I have. When I go to the market, people ask me how many kids do you have, I say I got 2 only. I don't want to say this guy because it is like quite dumb. Okay, but there is a very good reason why we design this thing. It is still used this day as a signal amplifier. So the reason is that whatever that connects to this hub, later they will receive the data, a piece of this data, and then that is the reason we can use this as a signal amplifier. When the signal become weak, then you can use this to amplify the signal. Right, so for more detailed comparison between these two, I'll show you in the next lecture. Right, now before we go back, before we end the class, let me finish the slide. Okay, now we go back to the slide and we just have one more thing to finish up. I want to finish up all the cables that we have here today, and for the rest of the slide that I skipped, I will cover back in the next lecture. Right, so the last one here I want to talk about is about fiber optic. Okay, now we have seen so many cable today. You know what is a serial cable? This one is used to connect router to router. This is a console cable which we use to connect router to a computer so that we can configure the router or a switch. Okay, and then this is Ethernet cable which we use to transfer data and build network. Now the last one today is a fiber optic cable. This fiber optic cable is very thin. I don't have something to show you today because this kind of cable is very fragile. Once you like touch it a bit, you bend it a bit, it will break, and then you cannot use it. And it's also very, very expensive. Okay, now remember when I start this class, I say that in the early day, the network is very localized, meaning that the machines in our country may not be able to talk to the machine which is quite far away, maybe in Taiwan. Right, after we have fiber optic cable, things start to change because fiber optic cable can span very long distance, and then the data transfer is very high speed. Okay, the reason is because in a fiber optic cable, traditionally in a DSL or a copper cable, we use electric signal. Means that 1010, all the data bits come from electric signal. Turn on, turn off, turn on, turn off, turn on. Now when we transmit using fiber cable, the data is transmitted using light source, light. So it's like I can point a pointer to a mirror and then it will reflect. The same concept happens here. So if you look at this diagram here, okay, you see the difference is that the transmission happen in a fiber one is very fast. In 1 second, I can send so many different signal compared to traditional one where we use electric signal is slower in terms of the bit rate. So what I want to say here is, if you use a fiber cable, you can send more data at a given time because like you see here, the light source is used and light is very fast. You know the speed of light, it is travel so fast. And then if you see this reflection, okay, I'll show you again. You can also see that first thing is the transmission is faster if you use the one at the bottom because it's fiber optic cable. Okay, and the reason is like what you see here shortly now here. the light will bounce. When the light go inside the cable, it will bounce, and every time you will see here is like 1010. So it can be like 1010 based on depending on whether is the signal is up there or down there. It can be 1010 like that. So you can use this to transfer data, but the difference is this is way faster than what we have. And because of this, you see here the undersea internet cable are all mostly fiber optics, meaning that now it is possible for us to connect Malaysia to Taiwan to US to China very fast, because we will have all these cable that we put under the sea, and it connects country to continents to so on, and then we can go so get everyone want to use today Instagram or Facebook. Some of the server is not here, it is in the US, but we can still like go there very fast because we have all this undersea cable. Okay, so yeah, you can also see, but of course good thing always come with a price. This is a picture where the shark go and bite the cable. So guys, what you see here is actually the cable is the undersea cable that I just talked about. It's all fiber optic, which is why it can support so much traffic across all the countries ma. But if you put it in other people's home, this is like habitat of others people like under the sea. We don't know what happened. And guys, if you remember one of the time, I don't recall when is it exactly, but I think 2 to 3 years ago, okay, there's once where there is few day we don't have internet, got few day, I think 2 or 3 day, because of this guy. Okay, this shark here, this guy go and bite our cable, and then we lose internet for a few days. If you still remember, they said that internet is disrupted because of this shark lah. That guy, now we found him, that is the guy who bite our cable. Okay, but that is what I want to show you here. And then the next one is a telephone cable. Now telephone cable, this slide you guys can just skip it because it's a very old thing, and we don't actually see this kind of cable anymore, so you can just skip the telephone cable lah. Right, so with that, I think I will stop here, and then starting before you go, I want to play you a video. I play a video to show you what is the internet, and then that's all for today. Yeah, and then also we have QR code. I'll share your QR code to you so that you can scan your QR. Right, while I generate the code, I also play the video for you. Okay, today is wait, I'm generating the QR code now. Almost there. Very soon you can eat your dinner already. Can ask your boyfriend to start the engine first. Almost scan one more QR, then we can go. Okay guys, yeah, that's it for today's class. Thank you for joining me. You can now scan your QR code, and then I'll play you a video which I find it very interesting. So today, to sum up what we learned the local area network. So you already see like all the device that you need to build a computer network. Okay, there is router, there is also hub, there is also switch, right? And then now there's also three things, and then you also see what is a local area network. So now you know internet is not one device, it's not like this one device that I'm holding in my hand, the internet. So I need to be very careful with the internet. If I break this thing, the whole internet spoil. It's not a device. Internet is a collection of all the network together, right? So with that, I play you one video today to finish the class, and I'll see you tomorrow on the next lecture. Bye bye.
What is it?
This, Jen, is the internet.
What?
That's right.
This is the internet. The whole internet.
Yup. I asked for a loan of it so that you could use it in your speech.
It's so small.
That's one of the surprising things about it.
Hang on. It doesn't have any wires or anything.
It's wireless.
Oh yes, everything's wireless nowadays, isn't it? So I can really use it in my speech. What if someone needs it?
Oh, no. People will still be able to go online and everything. It'll still work.
Oh, good.
I tell you, you present this to the shareholders and you will get quite the response.
Can I touch it? Ooh. It's so light.
Of course it is, Jen. The internet doesn't weigh anything.
No, of course it doesn't.
Hey! What is Jen doing with the internet?
Mark said I could use it for my speech.
Are you insane? What if she drops it?
I won't drop it. I'll look after it.
No, Jen. No, this needs to go straight back to Big Ben.
Big Ben.
Yeah, it goes on top of Big Ben. That's where you get the best reception.
Alright, I promise I won't let anything happen to it.
No, Jen, I'm sorry, but the elders of the internet would never stand for it.
No, Roy, I spoke to the elders of the internet not 1 hour ago. I told them about Jen winning Employee of the Month, and they were so impressed that they wanted to do whatever they could to help.
Wait a minute. The elders of the internet. The elders of the internet know who I am. You've got to let me have it.
No, Jen, I'm sorry, it's just too risky.
Oh, please, Roy.
Oh. Well, Moss, has it been completely demagnetized?
By Stephen Hawking himself. Who sends his congratulations, by the way.
Well, if it's okay with the Hawk,
So, can I have it?
you can.
Oh, don't forget your speech.
Oh, thank you.